Hey guys, it's Miss Miller. Today we're going to be looking at horizontally launched projectiles, and we're going to be focusing on using kinematic equations in order to solve word problems with projectiles. You're going to be determining the range, the height, and various velocities of the projectile. So, in order to use those equations, let's go ahead and review them from your notes. The first equations we have deal with the horizontal motion of a projectile. Remember, the horizontal motion deals with x, that's moving left and right. And one thing we know about the horizontal motion is that it has a constant velocity. And remember in your notes, it has a constant velocity because there's no force acting in that direction. I'm going to go ahead and use a different color here from a horizontal motion. We only have one equation, and that is the equation to find the range. Now, when something is moving at a constant speed, there is no acceleration. This equation is your range equals your horizontal velocity times time. Now, we've already went over these. You've taken a quiz, so you might want to have these equations out as we go through these different word problems. So there's the horizontal motion. Now let's look at the vertical motion of a projectile. So vertical motion is up and down, and a few things to know, or something to note, is that if an object is moving down over time, then the displacement, the vertical displacement, or what we call delta y, has to be negative. That's going to be important in these problems that we solve. Now, there are three equations that we deal with the vertical motion, because we know it accelerates just like an object in free fall would accelerate. So we're going to use our three acceleration equations. The first equation is g equals our final vertical velocity minus our initial vertical velocity over time. Our second equation deals with delta y. We'll use this one a lot. Our vertical displacement equals 1/2 g t squared plus our initial vertical velocity times time. And then finally, we'll combine those two equations to create a third equation that is helpful for finding a vertical velocity. And there's our equations. And again, you should have all of these already written in your notes, so make sure that you pull those out so that they're handy while we work on these problems. All right, one thing before we go on, remember that g is our acceleration due to gravity, and it's the same number. It's a constant based on the Earth's mass, and g equals negative 9.8 meters per second per second. Also, remember, I don't write meters per second squared because that has no physical meaning. We want to say meters per second per second. That tells us that gravity causes things to accelerate by about 10 meters per second every second. So just keep that in mind as we go through these problems. So when solving a problem, okay, you always want to make sure that you draw a picture and model the motion. We're going to use arrows to represent speed. And if it says it's being launched off of a table or a cliff or something, then we're definitely going to draw that in our picture. And we're going to label different parts of our picture to help us determine our values. We will list the unknowns, and then, of course, we're going to treat this just like a big puzzle, and we're going to solve those variables. Now, one method that I find helpful, the guess method. So we are going to list our given information and our unknown information. Then we're going to go back and look at our equations and see which one we need to solve the puzzle. We will substitute the numbers in for the letters in the equation, and then we solve. That's when we get our calculator out and basically plug and chug. So we're going to do a few examples together, and then you'll be left to do a few of these on your own. It might be helpful to even draw a table for each problem. right, let's go ahead and look at number 1 here. I'm just going to get myself out of the way there. A cannon shoots a projectile horizontally at 50 meters per second. So, one thing to know, when an object is launched horizontally, VIY is always equal to 0. In all of the problems that we do today, because we're talking just about horizontally launched projectiles, VIY is going to equal 0. So, a cannon shoots a projectile horizontally at 50 meters per second from the top of a 70-meter tall cliff. How much time does it take the projectile to reach the ground? What is the range of the projectile? So, I'm going to start by drawing a picture. And the projectile is going to start up here, and it's launched horizontally. Because it is launched horizontally, that means it has a horizontal velocity. And let's go ahead. This is given to us. Vx equals 50 meters per second. Now also, while we're looking at this, you might want to have your variables handy as well. If you see a number with meters per second beside it, don't plug that in for time. Make sure you know it's going to be one of the velocities, Vx, Viy, or Vfy. So knowing your units is going to be really helpful in solving these problems. Now, the cliff is 70 meters high. The fact that it's talking about a height tells us delta y. So I actually know, or I am given, delta y. Now we have to be careful here. This cannon is going to shoot off of the cliff and land below where it started. So that means that my delta y is negative. So delta y is negative 70 meters. That is all that's given, but I do know that g equals negative 9.8 meters per second, and I know that VIY equals 0. I know that because this is a horizontally launched projectile. The only time VIY would not be 0 is if it was launched at an angle, but it's not launched at an angle. It's just launched horizontally, okay? There's no upward component or downward component here. So I've listed my givens. My unknown variables, I don't know a final vertical velocity. I don't know time. And I don't know my range, delta x. Now, the question says how much time does it take? So I'm going to have to solve for time. The question also says, what is the range? So that means I'm going to have to solve for the range here. Now we can go back and look at our equations. So in this case, if I want to find time is in this equation right here. But I don't have range, so I can't use this equation, this first equation here, to find time. So I'm going to look at my equations on the vertical motion and see if I can find time. I'm going to start by looking at this equation. I do not know VFY, so I can't use that equation to find time. I don't know VFY, so I can't use this third equation to find time. So I'm going to use my second equation to find time. Let's go back and look at how that works out. So I've listed my givens, I've listed my unknowns. Now we're going to look at our equations. So to find time, if you have delta y, you use this equation. Okay, and now we can substitute and solve for time. So delta y equals negative 70. This is where I put the numbers into the equation. G equals negative 9.8. Remember, the problem will never tell you what G is, but we know because we've already learned about free fall and projectile motion that gravity pulls everything down at the same rate. Now, if my VIY is 0, this whole term here goes away because 0 times any number equals 0. So now we're just going to solve. So again, I listed my given variables, I listed my unknowns, I listed the equation, then I substituted. Now we're going to get our calculators and solve. So negative 70 equals 1/2 times negative 9.8 is negative 4.9. My objective is to get t by itself, so I'm going to divide both sides by negative 4.9. And I'm left with t squared equals negative 70 divided by negative 4.9. Let's go ahead and see what that is. Negative 70 divided by negative 4.9. That is 14.3. Now I have to get rid of the square, so I take the square root. So t equals the square root of 14.73, and I get roughly 3.8. I need to include units, and the units for time are seconds. So now I've found time. Now we need to find our range. So if I go back and I look at my range equation, I have Vx and I have time now, so I can use this equation to find range. Delta x equals Vx times t. So here's my equation. Now we substitute. I don't know delta x, that's what I'm trying to find. My Vx is 50 meters per second, and my time I just found to be 3.8 seconds. So it's kind of just like a big puzzle. So 50 times 3.8 gives me a displacement of 190 meters. And there's number 1. Let's go ahead and look at number 2. A ball rolls off the edge of a table that is 1.1 meters high and lands 2 meters away from its base. How much time does it take the ball to reach the ground? So here's another problem where we are going to have to find time. Let's go ahead and think of our picture. So we have a ball rolling off the table. Now when it rolls off the table, it's moving level. So this is a horizontally launched projectile. I'm going to list what I know or what I'm given. My initial velocity is equal to 0 meters per second. Remember, anytime something starts out level as a projectile, its VIY is 0. I also know G is negative 9.8 meters per second per second. Now I'm going to look at the problem and see what numbers I need to deal with. 1.1 meter high. Height is talking about my change in height, which is given by delta y. Now my change in height, when this goes off the table, it's going to end again below where it started, so delta y is negative 1.1 meter. These negatives are important because if we end up not plugging in a negative, we could get a wrong solution. Because acceleration and velocity and displacement are all vectors, which means direction matters. All right, delta y. Now, we land 2 meters. So this is 2 meters, and that's a range, so that represents delta x. So that's all of my given variables. Now we can list our unknown variables. I still don't know VFY. In the last problem we didn't need it, but I still need to write down what I don't know. I don't know time, and in this case, I do not know Vx. And if you're not sure, make sure you have a list of all of these variables and you can easily figure out what you do know and what you don't know. So now we just need to figure out, well, what's the problem asking? How much time? So I'm going to have to find time here and determine the speed. I'm going to have to find Vx. So looking back at my equations, I cannot find Vx until I have delta x and time. So I can't use my horizontal motion equations just yet. Let's look over here at my vertical equations. I don't know my vertical velocity final. I don't know Vfy, so I cannot use 1 or 3. I'm going to have to use the third equation again. So let's use this equation to find time. Delta y equals 1/2 gt squared plus VIY times t. Negative 1.1, now I'm substituting now, negative 1.1 equals 1/2 times negative 9.8 times t squared. Remember, if VIY equals 0, that term goes away. Negative 1.1 equals 1/2 times negative 9.8. Oh, let me just go ahead and simplify this. Negative 1.1 equals negative 4.9 t squared. Divide both sides by negative 4.9. T squared equals, I'm evaluating at this point. We're solving negative 1.1 minus negative 4.9. That gives me 0.22. Now we have to take the square root, so t equals 0.47 seconds. So now we have time. Now, since I have time, can I find Vx? Well, if we look at our equations, sure I can. If I have time and I have delta x, I'm going to be able to find Vx. I only have one equation with Vx in it. Delta x equals Vx times time. So, now let's substitute. Delta x is 2 meters. Vx is what I'm looking for, and time is 0.47 seconds. So now we're going to divide by 0.47 on both sides, and I will get that my horizontal velocity is 2 divided by 0.47. Let's see what that is. 2 divided by 0.47. It's a little over 4 meters per second. All right, let's look at one more problem together here. Okay, this one's a little different, so it's good to do together. A stunt car traveling toward the edge of a cliff at 25 meters per second lands 50 meters measured horizontally from the edge of the cliff. How much time does it take the car to reach the ground and determine the height of the cliff? So let's go ahead and write what I know. It is, we can assume, we have to assume because no angle is given, that it's launched horizontally. I know that VIY equals 0. I know that G equals negative 9.8. Guys, if you're not sure where to start, writing these two on these problems is a great start. Okay? At the very least, we know this. Now, 25 meters per second is how fast the car is moving as it creeps towards the edge. So that's its speed right here. That represents a horizontal velocity. Now it goes off the edge apparently, so this is not a great situation here for this car, and it lands 50 meters, okay, from the edge of the cliff. So that 50 meters represents a range, or delta x. So that's everything I know. Now we can write our unknowns. I do not know my final vertical velocity. I do not know time. And I do not know my change in height. Okay, I don't know how high this cliff is. So, first of all, how much time? Let's find time first. Because I don't know delta y, I can't use my delta y equation, or the one that we've been using, to find time. I'm going to have to use a different equation. So if we look here at our equations again, now I can't use an equation from the vertical motion, but I know delta x and I know Vx. So finding time is going to be much easier in this case. I'm going to use this equation. Delta x equals Vx times time. Delta x is 50 meters. Vx is 25. So now we can solve for time. Time is going to be 2 seconds. Okay, now that we have 2 seconds, or now that we have time, we can find the height of the cliff. The variable representing height is delta y. So let's look at our equations. Right here, I can use delta y, plug in my time, and I will be able to determine the height of the cliff using that second equation that we've been using today. So delta y equals 1/2 gt squared plus VIY times time. My initial vertical velocity is 0, so that term goes away. Delta y is what I'm looking for. That's going to be negative 9.8. Now I have my time, which is 2. So I'm going to plug this into my calculator. Negative 4.9 times 4. Because 2 squared is 4. And so that gives me 19.6, or negative 19.6 meters. Now, I want you to think about what that negative means. That negative just tells us that it actually ended below where it started. So that makes sense. Gravity is going to pull that car down as it comes off the cliff. Alrighty, you guys have about 3 questions to work on your own. I will provide the solutions, but I would like to see you do the work to get there.